Okay, I think we're ready to go, Michael. So good afternoon and welcome to everyone. This is XBOSoft's second quarterly webinar of 2018. My name is Steve Gores and I will be your host. Today we have our special guest and good friend, Michael Ma. He will be giving us a roughly 45-minute presentation on what I find a fascinating topic of defect patterns in Agile and Waterfall and what they mean to you. There's also another way of looking at the title of his webinar today, and we were kicking it around of one title or the other, so we decided to go with both. But he also had from nuclear submarines to widgets, and test defect rates and what they mean for you. So you can see during his talk, he will be covering a wide range of applications of how he goes about doing this. Today, as I said, I will be the host. I'm Steve Gores, and I manage the sales and marketing at XBOSoft. Phil, who typically runs these webinars, is caught up in travel and has passed the baton to me. Right. Let's see. Okay, we have a few either house rules or webinar notes. As participants, it's Michael and I will be doing the talking, and as attendees, you are muted. The best way probably to, if you have questions at any time throughout the webinar, please feel free to send them in. I think with this platform, we can either use the chat function or Q&A. I'm not exactly sure, so we'll see how that plays out, but feel free to ask, and we're leaving time, roughly 10-15 minutes at the end of the webinar to address any questions. If for some reason we don't get to them, they'll certainly be addressed and posted on our website following the webinar. Couple other items. Let's see. So at XBOSoft, again, we are sponsoring the webinar. We were founded over 10 years ago. We do have a global presence in QA and testing, and that's 100% of our business is focused in that area. We provide consulting services as well as testing services where we supplement or augment people's QA teams. So with that said, I'll pass it on to Michael and carry on, Michael.
Thank you, Stephen, and welcome everyone. Can you hear me well, Steve?
Perfectly.
Okay, great. Okay, so my name is Michael Ma, and I'm the managing partner of a firm called QSM Associates, and QSM stands for Quantitative Software Management. I'm also the past director of the benchmarking practice at a Boston-based IT think tank called the Cutter Consortium. And I've been working with both Cutter and QSM for, gosh, over 2.5 decades now on looking at productivity patterns and statistics from thousands of projects that we collect worldwide. And today's webinar is going to be giving you a sneak peek into patterns that we see that are especially powerful and useful from a QA and development and test perspective. And we'll be talking about what you can learn from them. And it's no joke. We're going to be talking about from nuclear submarines to widgets. I'm also someone who studied how to resolve conflicts internal and external. My graduate work was at the Harvard Program on Negotiation, which is a consortium of MIT, Tufts, and Harvard Law School, to look at how to resolve difficulties and conflicts in and outside of organizations. So I also take a lens about how to use data as a way of getting collaboration. It's an exciting mesh of disciplines, so to speak, and we'll be talking a little bit about that. On the side, something some people know about me, I'm also a private pilot. I love to fly Cessna and Piper aircraft, and I'll cruise around over the hills of western Massachusetts where I live very often. So let's talk a little bit about where this research is sourced. I'll be making reference to something called the QSM SLIM database, Software Lifecycle Management. And about 13,000 projects now are in our resource library that gives us insights into patterns of how projects behave, what we can learn from them, and also how we can predict them. So we've got data on both waterfall and agile projects, everything again from nuclear submarines to widgets, in-house, offshore, outsourced, development as well as maintenance. And a lot of our resources and research is actually embodied in a family of technologies called the SLIM tools. Some of you may have heard of our flagship estimating model, which does predictive forecasting, as well as our benchmarking database. A lot of our work is also published in several books, 5, 6, 7 books, as well as several dozen, if not 100 technical papers published through the Cutter Consortium, where I was the editor of the IT metric strategies. So let's get into what we're talking about from our research data, which also includes a lot of household names in the software and technology industry. So everything from a wide variety of application types. We see patterns on schedules, time to market, effort, defects, team sizes, small, medium, and large projects all across the spectrum. So we're going to pull together some of that research and talk about today's topic, which is about defect rates in Agile Waterfall and from nuclear submarines to widgets. So this is a widget. I actually had the privilege of working with a team that was part of this credit card scan, mobile scan, for recording a charge purchased through a device that goes into your iPhone or Android device. And when we look at patterns on how the code progressed from design, development, and test, we found defect patterns. And interestingly, a shape of a defect curve that was recorded as we went from the start to the finish. And it has a common unifying pattern that we also see in projects as complex as the navigation system for a Trident nuclear submarine, which before I wound up joining QSM, part of my career was in aerospace, and I was the QA and test manager for the development of the navigation system for this ship. This was the Trident II. No windows, so you have to fly this by instruments. And while we were in development, we wanted to be able to predict what our QA strategy should be, and we were tracking defect patterns and defect rates as the code was being built over time. And so this is what we call a Rayleigh bug or defect curve, and it's named after a 19th century British mathematician. That's where the name Rayleigh comes from. And it simply refers to the fact that patterns on development of knowledge-based systems like software follow a curve that builds to a peak and then has a long tail. So if you look up someone named Sir John William Strutt, he was the third Baron Rayleigh in British physics, a physicist from Cambridge University, and he first described the Rayleigh shape. Later on at IBM Research Laboratories, a gentleman named Peter Norden identified the Rayleigh shape in research and development projects for IBM mainframes. And so that was an area that we also observed it. And in software, Larry Putnam Sr., who's the chief scientist of QSM, our firm, identified this pattern as well in bug rates for developing code, going through development and test. So it's also known as the Putnam-Norden-Rayleigh curve. Now, all knowledge-based systems under development exhibit this curve when it comes to, say, bugs, whether you're building a nuclear submarine application or a widget for a credit card swipe. Typically about 2/3, 3/4 of the way into the curve, 70% in, where the remaining 30% is QA and regression testing. We're on the tail end of that curve after reaching a peak. Now, if I could see or hear you, if I posed a question to the audience, I would try to gauge what your impressions would be about what contributes to this curve. What makes it bigger? What makes it longer? What would shrink it? What would make the peak lower? So if we had really clean code as we were building an application, we'd see a very small Rayleigh curve with a lower peak and a quicker tail. If we were building something that was buggier, we would see a large curve with a higher peak and a longer tail. So here's where we're going to be talking about, well, what are the drivers of what makes this curve long and high or short and squat? So think about that for a minute, and I'll throw out a couple of thoughts about what we see. Some of you might say, well, you know, when we're talking about something that's more complex and difficult to do, we might find more bugs in the code that have to be tested before a system is ready, and that would be correct. Something of lower complexity might have a shorter Rayleigh curve with a lower peak. Another might be the experience of the team. So if you have people that are fairly new and have a large learning curve, they might have, you know, more bugs in the code that they would then have to find and fix and test, as opposed to a team that's highly experienced, highly skilled, and they really are familiar with the application, and they tend to write cleaner code right off the bat. Another factor might be if you're thinking, well, if a project is under time pressure and an organization decides to ramp up with double the headcount and try to compress time, intuitively we would say, well, clearly if we're trying to compress schedule and throw a lot of people on a project, we'd have not fewer defects, but we'd have more defects to have to contend with as people were rushing, and you would be correct. So these are the kinds of things that we want to think about when we think about our own potential bug curves, and I assure you that inside your projects, whether you have it transparently visible or not, your projects exhibit a bug curve. So how can we leverage it? What can we do about that, given that we know that we probably have a curve in our projects? So I talked about the part of the curve that goes into regression testing, and up until the point we feel that this is that swipe project, mobile encrypted swipe, and it's a team during the story phase, which is about 2 folks defining the story work, and then during the build and the red curve, we have 4, 8, 7, 8 people going out to May, and we capture the bug counts that are in QA and regression testing, and that's that blue circle. So that's that number 61 there. So that number can be low, or it can be medium, or it could be high, depending on the characteristics in your environment. And so look to the right. When I sketched this project out with the company that was building this mobile encrypted swipe, I said, what are the things that were impediments and negative impacts that might have made things more difficult, might have even driven the bug curve higher? And they listed an enforced deadline, losing critical staff, multitasking interruptions and things like that, churn on the actual hardware devices that they were using for the swipe. Those were challenges on the project that might create more rework. On the green column on the right, what were things that were positives that actually worked out well? Well, team cohesion, really motivated team, a strong product owner, exciting technology. So those were things operating in favor. So think of those two competing forces as what either contributes to the difficulty or the success of a project, and by that definition, maybe whether the bugs would be low, medium, or high. And how would we plot this project if it was a certain amount of code, in this case about 40,000 lines of code? They found about 61 bugs in the code that had to be found and fixed. And how would that compare, say, against an industry trend line, low, medium, and high? So this next chart actually shows us how we could benchmark defects in a project that might have recently been completed. And that's coming up here. And this is a trend line. So So what you're looking at here in the solid black line is reference data from the QSM industry database, and that is the average amount of defects found and fixed in the code for small projects on the left, medium-sized projects in the middle, and larger projects on the right. This happens to be a case study of looking at the bugs found during testing in one company, and it happened to be a medical devices company. And they had a couple of projects that were large waterfall projects with teams that went 20, 25, 30 people, building anything from 150 to 250, 300,000 lines of code. And those are the blue squares that are on the right side of the graph. They were very large projects over a year and a half. And we compared the number of bugs found during testing against the QSM industry database. And how to read this curve is that if you're above the line, you're finding more bugs in the code than the industry average. The upper hash line is the upper limit for the one standard deviation upper bound. Now, this organization then made a transition into Agile co-located pair programming, and 3 of the first projects that were fielded in that environment are the red circles on the left. And we looked at the number of bugs, just like you saw in the previous graph, found and fixed during QA and testing, and plotted those against the code sizes, more on the smaller and medium size, and looked at how they compared against the industry average. So you can see that what we've got here is a rather different pattern where 1, 2, 3 projects were significantly below the industry average, and they were on average about half the number against the industry trends. So when you're looking at moving from a scenario where in the traditional environment they were about double the number of bugs that were found and fixed, they went to half. So if you're going from double in one case, which is right here, to 50% fewer, your end-to-end reduction in defects in terms of code density is a factor of 4. So you went from twice the industry average to half the industry average. You've effectively reduced your defect density by a factor of 4. And in this environment, that's what they were going for. So whether you are trying to build code for a nuclear submarine, or in this case, medical scientific systems for blood analysis, you want to have as few bugs in the code as possible. So they were successful in that standpoint at bringing down the defect density in their code by a factor of 4. And that's something that's pretty powerful to convey to your management. So that, I would say, is a success. And if you were thinking, should we do more work that's in a pair programming co-located team environment, think of XP, Kent Beck's environment. In this case, it was successful, and you may want to do more. So let's talk about bugs. Let me erase all of these circles here. My eraser's not working. All right. And talk about a little bit about time compression, going for speed, with this whimsical image of a guy screaming down a racetrack going for speed. We find from the data something that's also correlated to defect rates that is non-trivial, and that's schedule compression. So if you have a situation where you have the liberty of taking a little time and using a smaller team, you tend to have less waste on a work, on a job, on a release, and more real work gets done without the chaotic waste of rework and mistakes. But as schedule compression becomes more of an issue, and let's say you are asked to compress the deadline by throwing a lot of people on a project, you tend to get what we call optional chaos. And we tend to see a much higher amount of rework and a higher amount of defects in the code when we're in this situation. I'm going to throw a hypothetical question out there, and I don't think I can see your hands or your body language, but if I double headcount and I try to compress schedule, going from a team of 10 headcount to 20, how many more defects do you tend to expect you might find in the code? And the question might be, do you expect to find double the number of bugs in the code if I double headcount? And would it be triple? Would it be 4 times?
I'll go geometric.
Yeah, it's geometric. It's actually about a factor of 4 to 6. So if we go to 20 headcount from 10 to try to compress schedule on a project that's, say, a 10-month schedule, and the boss says, I want it done in 6, double the headcount, we actually can't compress it to 6. The most we tend to see is about a 20% compression. We'll shrink 10 months to 8 months, but we'll drive defects up by a factor of 4, if not 5, if not 6. And that's something that we see quite often in the data. It's called the inverse fourth power trade-off law. It's actually published in all of our books. And that's something to keep in mind. So if on your project, you're on a highly compressed project with a rapid ramp up of headcount, you should expect that you may require more QA and test professionals on the back end of that life cycle in order to clean out the code to be ready for delivery. And you should be wary or aware of the fact that the ratio of your developers to testers might require more testers because of that schedule compression, as opposed to a project that might have a more relaxed schedule and a smaller team meeting a certain date. Now here's the other extreme, where instead of ramping up with double the headcount, what if we do something like we just pair? We build systems like in the Kent Beck XP co-located idea. And if you have like a pilot and co-pilot, and I'll talk about this as somebody who flies airplanes, do you tend to expect that you would have cleaner code or less clean code? And a lot of you would probably say, we expect we'd have cleaner code. And you would be right. Because if you're working in pairs, what we find is that there's an instantaneous code review. And before mistakes wind up in the code and then have to be later found on that Rayleigh curve during test, they're captured earlier. So sometimes we find that the peak of that Rayleigh curve is actually shifted left. And you'll see in the title slides, you might have recalled before this webinar really got going that it was a hashtag shift left. That's the idea of being able to find defects earlier rather than later. And just like in health, say if you're worried about finding a tumor, early detection is always better than later. And so we see that when we look at teams that do pairing, their bug curves are lower. And indeed, in this organization, when we plotted 1, 2, 3, 4, 5, 6 releases from 5.0 through 8.0, when we plotted their bugs against the defect curves in the QSM database, we found 50 to 60% fewer bugs in the code, a shorter Rayleigh curve, a Rayleigh curve that had a lower peak than industry. Now think about this for a minute, and I'll put out another suggestion or question. If you have fewer bugs in the code, do you think you'll be at time to market faster, or would you be longer? And those of you who are probably nodding your heads are saying, well, we're going to be time to market faster because the code will be ready and ready to be at market because we're finished sooner. And you would be correct. So this is an organization, actually, that's one of my favorite clients that I've worked with for over a decade. They're a company outside of Chicago called Follette Software. And they've given me permission to share some of their case study data in webinars like this. They are like the Amazon.com of school supplies for K through 12 school systems and for universities, higher education, creating lesson plans, running bookstores, and furnishing classrooms with everything that they need. And their mission is to empower the next generation of children through education. Let me show you a little bit of data from them about way back when we did a benchmark when they were considering whether they should offshore or stay the course with their pair programming Agile environment that they had just spent a lot of time on. And so I collected data on their behalf on 6 releases recently completed and compared their performance, which is in that curve that says current performance on average, against the industry average in our research database. And we found that for their cluster of projects, which averaged about 400,000 to 500,000 lines of code, they were building it at about a $2.2 million cost, which was $1.3 million cheaper than the industry average of $3.5 million. They were finishing at about 7.8 months compared to an industry average of 12.5 months, 12.6 months. So almost a full 5 months faster. Their defects found during QA, which is that latter 1/3 of their Rayleigh curve, was only 121 bugs that had to be found and fixed compared to an industry average curve, which was 242. And so there you go. The pair programming co-located teams was really working. With an average headcount on their team sizes at about 35, give or take, which was exactly the same as the industry average team size for that class of work and that size. So I basically summarized to them, you're building systems at 1.3 million cheaper, 5 months faster, with half the bugs or twice the quality compared to the industry average in your environment. Congratulations. And they said, well, what about if we were to just look at offshore and outsourcing statistics? And I said, okay, well, let's talk about that for a minute. So instead of people co-located in one room working in pairs, they were spread across multiple cities and in some cases multiple continents. And what we found when we looked at that data was the average cost for offshore projects was not 3.5 million, but only 3.2 million. But still, it was $1 million more than what Follette was doing in-house. And not 12.6 months, but more like just under 10 months, 9 months, but still longer than what Follette was doing at 7.8. But the key thing that was really a kicker was the fact that the QA defects, instead of 242 for offshore projects that were spread around with development teams in multiple areas, was actually 3 times higher. So it was about 735 defects instead of 242. And staffing was not 35 folks, but it tended to use a larger headcount team of more like 50 folks. So I said, well, you could abandon your co-located teams that are all located in one room with pairs, but it would cost you $1 million more and take 2 months faster, and your bugs would be up by a factor of 6. So in that case, it was pretty clear. Stay the course, continue with their Agile, because they were building really clean code, and that was really a very celebratory conclusion from the benchmarking data, which we were able to do for them in a matter of about 4 to 6 weeks. So the idea that we're really looking at next is, if you've got this kind of capability, what about the notion of creating value and profit will follow? And that's where they're going now. They're moving into taking this machine and applying it to being able to build things that they know are going to really impact their market, disrupt their marketplace, and create more market share. And that's where they're going. Some of this research is in a great book that I highly recommend by my friend and colleague Mike Cohn, Succeeding with Agile. In chapter 2, I believe, you can read more about this QSM research and defect patterns and trend lines in this book. So feel free to get a copy of that if you're interested in reading more, or contact me or Steve. Okay, so now that we know where we were in the past, what about predicting the future? Can we use this idea of knowing how defect curves behave to create a crystal ball effect? And well, the answer is yes. So how would we do this? So I'm going to use a little metaphor. Being a pilot and somebody that really loves flying Piper aircraft, one of the things that I leverage and take advantage of is radar flight following. So if I depart my local airport in Western Massachusetts and I'm climbing through 3,000 feet and I'm heading towards Boston, I will sometimes dial up my radio frequency for Bradley Approach Departure Control in Hartford, Connecticut, and asked them to pick me up on their radar to track my progress in my little blue Piper plane. There it is, affectionately known as the Blueberry. November 7629 whiskey is my call sign. And I'll have them track me and follow my trajectory and predict my curves. So there I am with a fellow who actually I enjoyed flying with out in Seattle, Washington in a seaplane. Here's a nice little shot of the mountains of western Massachusetts where I live and keep my plane. Beautiful sunset over the mountain ranges near Hancock, Massachusetts, wind farms. So we'll use radar flight following, and we'll look at the curves and the trajectory of our flight. And I'm going to use it as a metaphor to talk about the curves and trajectory of a software project from a standpoint of the defect curve. So here we go. Let's talk about the idea of looking for patterns in real time in flight, much like if we were to depart a local airport and head on a flight plan. Now, along the way, we may wind up wanting to steer clear of weather, which is those red dots and yellow dots, and make sure we don't get into a situation where we could have a problem with weather, and we want to safely guide our way through, just like we would safely navigate our project. And what flight following does in, say, the software realm, and I'd encourage you to think about this if you could apply this in your world, is to look at your bug curves. Look at the number of bugs that you may be finding and fixing over time. And this is a chart in one of our models that looks at the expected Rayleigh shape for defect data that we're finding as we are actually building and testing the project in real time. And we are plotting, in this case, at the client's organization, the blue dots of the number of bugs that they were finding during testing. Now, you'll notice that this is a pretty spiky curve, and indeed that was the case. This is a project that was a banking application, so it's in the financial services sector. They were building under incredible schedule pressure. They had ramped up with about 70, 80, 90 people, and when they got to testing, we started tracking the bugs in their QA environment by week. So I think we might have been plotting it weekly or bi-weekly, and that's the blue dots. What we did was we overlaid our mathematical Rayleigh curve onto the blue dots until the model did a radar lock to say you are riding this curve, which is in the red, with a green pattern that kind of goes around it, plus or minus 20%, and then a yellow danger zone above and below the mean. Plus or minus maybe 30% or higher. And when the model locked on to the fact that they were riding this curve, even though it was noisy and spiky, we did a rolling smoothing, we were able to look ahead and see when they would be at the point where the curve was riding down to that tail where 90% of the bugs will have already been found and fixed. And what would that forecast be? It would be in the late October, early November timeframe. This is one of the earlier projects where we really found remarkable prediction accuracy on just looking at the predicted schedule based on the bug curve from our mathematical models. And we came up with sometime around November, early November, late October, when the code would be ready for prime time. Based on what we were seeing in the actuals, which were really high and spiky, we expected that because of a very large team under schedule compression. So here's where we were like predicting the future, and it was like a GPS forecast into the future. Just like if you were in your car and saying, based on where I am so far, where am I going and when will I arrive at my destination? So that's the idea and the concept between when it comes to using these kinds of mathematical forecasting. So you don't know it, but inside your GPS of your Garmin Nuvi device that might be in either your car, or maybe you're using Waze or a navigation app on your phone, that's what's going on. So we find that we're able to not only predict the schedule, but using modeling, we can predict and forecast the optimum QA to development test mix of your development teams. So that's something that we find incredibly powerful because you're looking forward into the future, anticipating the future, and then managing your risk. So what are some of the lessons learned here as we kind of wrap up and I go into a period where we can discuss this through open Q&A? What do we find when it comes to domain knowledge and defect rates? Well, we find that when you've got smart and experienced people, you are really taking the idea of the science of knowledge work, which is what we're involved in software, and embodying it inside code, which runs on a machine and emulates human thought. So to the extent that you have highly experienced people versus lesser experienced people that might have a learning curve, that contributes to your bug curve, your Rayleigh shape, your defect density, defect rates. So keep that in mind. If you were to look at the makeup of your team, you'll probably see an influence in this dimension that will tell you a story about your bugs. Short feedback loops versus long feedback loops. We see the shape of defect rates and Rayleigh curves very closely correlated to whether people are able to have very fast turnaround on their questions and answers about solving problems. Again, this is knowledge work. The ideal situation is if you have pair programmers who are building systems side by side and all you got to do is turn your chair. And in some environments, some people work so well together that they finish each other's sentences. Or even as they're looking at their colleague writing the code, they might even intuitively know exactly where they're going and give them some ideas as they're moving through the code and solving the problem. And as a pilot, I experience this when I have a really skilled co-pilot. If I've got somebody who really understands the flight path that we're going on, really understands weather, knows the radio frequencies, has really good communication with air traffic control, and is really good at keeping altitude and heading, I feel really comfortable and secure because we've got two heads better than one, and we're making fewer mistakes, I can guarantee you, versus if it's only one person trying to solve it all on their own. So you have this accelerated learning and execution when you've got a couple of people face to face. And I didn't touch on this in the beginning, but when I was on the nuclear submarine program, that was way back when, a couple of decades ago, we did a couple of innovative things at that time, even though it was before Agile. We had people working in pairs. So in writing out these military specs for what the code had to do, we had people in teams of two. We had everybody in one giant room. There was maybe over 100 folks all in one huge room. So even if you weren't sitting physically next to somebody, you could actually walk around, right around to the other side, another aisle, and get your answer solved instantaneously and quickly. So we had people co-located, and that was very critical. We even had people coding in pairs. So you had a pilot co-pilot scenario there. Again, short feedback loops. And being the manager of the QA and test team, I actually wrote all of the tests before the code. So that might sound familiar. That's called test-driven development. And we did that. And it turned out, and it was a very good thing, that when we looked at the predicted defects that were going to be in the central navigation computer CNC code, along with the gyroscopes and underwater sonars, the defect rates on that system was extremely low, and we made our date. And those navigation systems have been operating, defect-free for decades. So short feedback loops. Avoiding burnout, one of the fundamental principles of XP, and if you read any of the books on pair programming and Kent Beck, sustainable pace is really important in avoiding burnout. Real adherence to not working 50, 60, 70 hours of overtime, because a tired mind is a mind that makes mistakes. So some people say, hey, we want to follow the 40-hour work week rule and not burn out and prevent productivity collapse. So that contributes to the defect curves, high, medium, or low. Transparency. One of the things that's really remarkable is getting true visibility about what's going on with the code, with the velocity, with the programmer productivity, and that's a good thing. But if you have things hidden, a good quote by Ken Schwaber, creator of Scrum, transparency is a great floodlight. You find problems really quickly and you solve them. But people who thrive in political maneuvering hate transparency and hate Scrum, and that's generally the case. High bandwidth communication. We find that the lowest defect curves and the cleanest code happens where teams have wide open pipes, where you can get that instantaneous answering of your questions without things being dragged out. Build a little less. This is an interesting puzzle. My kids used to love doing this. It's called the 15 puzzle. And if you're familiar with it, you got to slide these tiles all around until you get them in order. 1, 2, 3, 4 across the top row in the white. And then, the red and white alternating through the positions on the grid here. And I'll ask a rhetorical question. What's the secret to being able to solve this puzzle? Think about it for a minute. Maybe you have to have good hand dexterity. You have to know how to count. That helps.
How about knowing Michael Ma?
Knowing Michael Ma. How does he? Well, and Michael Ma will tell you that the key to solving this puzzle is having an open square. And when we talk about backlogs that a team has to build within the deadline, very often they've filled that last square and you can't move. So the idea of thinking about the size of your backlog and just dialing it back a little bit and leaving an open square allows the team to have enough latitude to move things around. So that's a key thing that I'm going to recommend to you. When you fill that square and you overfill the square, you're going to see bug rates that are going to climb. You're going to see that you're going to miss your deadline because you've taken on too much in too little time. But if you leave an open square, you'll tend to have a smaller and a shorter Rayleigh defect curve. So here we are, we're going into the home stretch, and then we'll open it for questions. Ultimately, the idea is to know thyself. It's a good philosophy to have. Our approach in QSM is that measures can go a long way. It's very easy to get a benchmarking readout about what do your defect curves tell you. If I asked you to capture a handful of metrics, 3, 4 metrics, the duration of your release, the number of folks in your head count, the size of your backlog, and the bugs that you found during testing, those 4 minimum metrics are all we need to do a trend line analysis to find out whether your bugs are above the curve or below the curve or right on the average. What are the things that are impacting you negatively and positively? Those are the things diagnostically that will tell you what's working and what doesn't. So it's kind of like if you go to your doctor and you say, Doc, what's my cholesterol? I'm really thinking about my heart health. And the doctor tells you your cholesterol is, 275. And the average among people of your age is 200. You're 75 points over what we would think is healthy cholesterol. And then we'd look at, well, what's your lifestyle? What's your positives and what's your negatives? And you say, well, Doc, I eat at McDonald's on Mondays, Wendy's on Tuesdays, Kentucky Fried Chicken on Wednesdays, and, Applebee's on Thursdays. And I just love lots of fried foods and all that stuff. Well, then, hey, we know why your cholesterol is going through the roof. And so the same thing with software projects. If you've got a lot of staff turnover, domain knowledge that's kind of got a big learning curve, your compressed schedules and things like that, you're going to have buggier code and you're really going to need some help. So, you'll have to call Stephen Gores even more frequently as an ER doc than less. And XBOSoft might have to really bring in skilled testers and help you get down that defect curve and clean the code and make you more at potential hitting time to market. So working with QSM, one of the things that we're doing in a collaboration is being able to provide this air traffic control predictive forecasting like FAA. So know thyself is really key. If you collect enough data points, 2, 3, 4, 5, you can even build your own trends, not have to rely on just the QSM database that's on the desktop and you can see it for your peer group in your industry, but you can build your own trends and say, hey, these are our trends from 2017. We've gotten enough data where we could do a curve fit through the SLIM tools and then store that and save it. Now we can look at how our 2018 projects are comparing against our 2017, and are we faster? Time to market on the upper left. Are we using more or fewer people on the lower left, average staff? Are we spending more effort or less compared to what we did last year? And are bugs during QA higher or lower? On the lower right. So you can kind of benchmark yourself. What about you? So with that, we're kind of wrapping up. I'll just give a summary of the technologies that we used for this webinar. We did the benchmarking analysis with a model called SLIM Metrics. It's on the right, analyzing and benchmarking projects after collecting the data on the lower part of the foundation of the triangle, storing and managing historical data. But we also do the predictive curves under estimating and planning, and also tracking and forecasting. Those are kind of those curve fits that I just showed you about looking at the Rayleigh shape. So as we wind up to a close here, we hope we've been able to convey this idea that we are looking at what defects mean in different environments, whether you're Agile and whether you're Waterfall. How you can use it from a standpoint of understanding not only your recent history, but what will it look like in the future on a project that's already underway, in flight, or projects in the future. We're here to help you. In fact, I think Andrea Gelli from our Swiss office is actually on this webinar as well. So if you're in Europe, you can contact Andrea, who speaks multiple languages and works in our European practice. I'm Michael Ma. My email address is there, michael.ma@qsma.com. And you can follow me on Twitter at Michael C. Ma. And we're here to help you, as well as Stephen Gores from XBOSoft. And I'll let you give a quick summary of XBOSoft, Stephen, and then we'll wrap it and open for questions.
Well, thank you very much, Michael. I even from a sales and marketing perspective, I found the information informative and interesting, and I was focused in the whole time. I think the next book I read may, in fact, be Michael Cohn's. But as a sales guy, I might look for the abridged version, but it looks like it could be helpful.
Well, go right to chapter 2, and you can read about my research.
Okay. And my only other comment, Michael, you had a much livelier shirt on the I think on the promotional mailers, the pink or purple one that really caught my attention. So go with that next time. I'll know what to step up. But okay, for our participants, if you have any questions at this time. Again, I would think maybe you could reach us via chat, or there's a Q&A option here. I'm looking at the menu, and again, not being an expert at this, I'm not sure which one to use, but feel free to ask, and we will address accordingly. Thank you.
Okay, well, one thing that I'll say to get things started is one of the most common questions that I get is, do we also look at defects by severity? Because no bugs, no two bugs are the same. Some might shut the system down and cause a system crash, and some might be cosmetic or stylistic bugs. And the answer is yes, all of the above. So one of the things that we do when we encourage people and say, what's the, the quick start idea about what we should capture in terms of bugs. I usually say start with what you find during a regression in QA and then break it out by severity category and look at what you tend to see for how the pie is sliced up for cosmetic, tolerable, moderate, and then critical or severe defect rates. So maybe severity, 1, 2, and 3 or something like that. And that'll give you some insights into the pattern of your defect severity, because not all defects are the same, and some are certainly easier to handle than the ones that actually bring everything down like a house of cards. And so that's one way to start. Another question that people often ask, and maybe I'll bring it back to, I'll go all the way back to that diagram, like how do we begin capturing information like this? And I'd say draw a picture. So if you remember, there was a sketch of that mobile encrypted swipe. I'm trying to get the system to respond here and go back to it, but we basically draw a diagram that says, where you have a timeline from left to right, starting at the beginning of the project through the end. Draw a sketch of the team as it built up to a peak and number of head count, and then write down the positives and negatives and capture the size of the backlog in terms of stories and story points, code counts, things like that, and then also the bugs. And if you capture that, it's kind of like you taking your own picture. You can even submit that to XBOSoft and QSM Associates, and we can generate a chart that shows you against a trend line of how your projects were performing. So the system finally woke up, and now I can go back to showing what that looks like here. And that might give you an idea, well, what do we collect? Stephen, anything else?
Here's a quick question. So what would be if a typical development team size where going through this, the effort would be have a good ROI? I mean, would a small company with 4 developers find benefit, or does it need to be something a little larger with larger teams before the effort to do this is rewarded by quicker releases and fewer bugs?
Oh, I think know thyself applies to everything from small, medium, and large projects. So I've sketched out projects like this where the average team headcount is 3 or 4. And the project's duration was 5 sprints. So, it was only a matter of 10 weeks, right? Okay. And then everything as big as something that goes up to a team size of 50, 60 people going out a year. And I think what you're going to find is that you'll see patterns that are different for projects that are large teams, long schedules, versus projects that are small teams, shorter schedules. And we often find that when we calculate productivity, you'll see there's a sweet spot, like there's an ideal team size that is being reflected in your environment. And that may be different for every different company or culture. So this sketch only takes about a half an hour, right? I mean, if you can't spare a half an hour, then, wow, you got some problems. But it's easy to do, and if you get 2, 3, or 4 of them, I will oftentimes go into an organization and in one day scoop up in my butterfly net 3, 4, or 5 projects. I was just recently down in Mexico City at the Department of Education for the government of Mexico, and we gathered a handful of data just in one day and charted them all up, and we found that their defect rates against trend were below average. And they tended to be that way for projects that took a little longer with smaller teams, right? But they missed their dates because their dates were too aggressive, and they didn't realize that they were over ambitious in terms of their deadlines that they promised to the client organization. So you got to be careful about that sort of stuff. And there's easy ways to get insights inside one day, even from gathering this data. So it's really not that hard to do, and once you do it once or twice, you can draw a sketch like this. I can teach you, and then you can do it all on your own.
Excellent. Well, I think that wraps it up, Michael. I don't see any particular questions coming in. Not that people may not have them, but again, you have our contact details. This webinar will be posted on the XBO website within a couple days, and we will be sending you an email for all participants with a link to that information. And again, feel free to reach out if you have any questions, either to Michael or myself, and we'll see if we can be of service in helping you expedite projects or improve quality or work together to achieve both of those goals. So thank you, and have a good day.
Great. Thank you, Stephen. And for anyone who wants to be able to have a team like XBOSoft and QSM, look at your defect patterns and help you ramp down or get down that accelerated curve, we're happy to help. Send us any questions you have afterwards. And also even use this recording and share it with any of your colleagues that weren't able to come today, but they can just follow along and play it at their own leisure. Thank you very much, Stephen.
Okay.